How do you write the equation of a line given some information? Here we have a line with point 1, 0 and 3, 2. Now, both of our starter equations, point-slope form, which requires a slope and a point, and slope-intercept form, which requires a slope and the y-intercept, both require a slope. Here, we don't yet have a slope. However, we can find the slope, remembering, of course, that the slope is equal to the change in y over the change in x, or else your rise over your run. Our rise here is 1, 2, and the run is also 1, 2. So doing this graphically, we can see that the slope is 1, 2 over 1, 2. That's 2 over 2, which is just 1. Or you can use the formula if you actually don't have a graph. We know that because slope is the change in y over the change in x, the change in y is y2 minus y1. And the change in x is x2 minus x1. Now y2, let's call 3, 2.2 and 1, 0.1. y2 is 2 minus y1 is 0 over x2 is 3 minus x1 is 1. 2 minus 0 is 2 over 3 minus 1 is 2. 2 divided by 2, still 1. So either doing it graphically or algebraically, we still get the same answer. Now what can we do next? Well, we have 2 points, neither of which, of course, is the y-intercept, which is why slope-intercept form often fails us. We have 2 points, and we have the slope of our line. Well, in other words, we have a point and a slope. We can use point-slope form, which is y minus y1 equals m times x minus x1. So, let's write out this equation. We have y minus y1. Let's use 1, 0 for now. So we have y minus the y value of this point is 0 is equal to the slope, which is 1, times x minus the x value of this point, which is 1. In other words, y is equal to x minus 1. So we could easily go from point-slope form to slope-intercept form by distributing our m and moving over the y1. Of course, the y1 is 0, so nothing really happens there. And then, of course, we can go from slope-intercept form to standard form by moving over the x. So here's negative x plus y is equal to negative 1. But of course, a can't be negative. So here we have x minus y is equal to positive 1, which we got by multiplying everything by negative 1. And so here we have our line in standard form. Here we have our line in slope-intercept form. And here we have our line in point-slope form. All 3 forms really easily gotten just by going through point-slope form. Now, what would have happened if we had used the other point for point-slope form? Well, let's find out. Y minus y1 is 2 equals m, still 1, times x minus x1 is 3. We can distribute the 1, so we have y minus 2 is equal to x minus 3. We can add 2. Y is equal to x minus 1. Then, of course, we can turn this into standard form by moving our x over. So we have negative x plus y is equal to negative 1. And we can multiply both sides by negative 1, yielding x minus y is equal to positive 1. Here's what we have here. We have standard form right here. We have slope-intercept form right there. And of course we have point-slope form right here. Point-slope form is the obvious, easier one to use. However, if you have to write it in the others, you could transfer point slope form into the others with good ease.